So we have that the water runs into a conical tank and the tank stand points down. So that means that we have a cone, kind of like an ice cream cone, with the tank down. The cone has a height of 29 and a radius of 20. So part A says, how fast is the water level rising when the water is 13 meters deep? So this is getting filled and this is full of water. So you have two things here. You have the height of the water and you have the radius that's changing. So the height of the water and dr. So we try and find the height of the water at a specific moment in time when the water is 13. So this is one of those that we're going to have to use similar triangles because we don't know anything about r and we want to write r in terms of h. So we're going to use the big triangle and the small triangle. Now I'm not going to put 13 in here. A lot of you guys want to do that. The reason I'm not putting 13 is because I want it for all moments and times, and the height is not always 13. The height of the water changes. So we're going to write 29 is 13 as, oops, sorry. That should be h. I forgot to change it back. So don't put 13. So 29 is to h as 20 is to r. So we get 29r if we cross multiply times 20h. So r is going to be 20 over 29h. Okay, so there we have the radius in terms of the height. So again, the volume of this is going to be given to you because we know that the volume is 15 cubic meters per second. So that is the rate of change of the volume. So volume of a cone is 1/3 pi r squared times h. So I'm going to go ahead and substitute that for r. Now before I take the derivative, I am going to combine all my h's together. So I'm going to have 1/3 times 400, because it's 200 squared, over 29 squared, and 29 squared is 841, times h squared, right? So the square has to be distributed to both, times h. So my volume is 1/3 pi times 400 over 841 h cubed. I multiply these together. So now I'm going to go ahead and take the derivative. I'm not going to substitute 13 because remember this is a specific moment in time and I want to find the rate of change for all moments in time. So dv is going to be now 1/3 pi 400 over 841 are constants, so I am just going to bring it down. I'm not going to have to do anything with them. I'll just bring it down. And I'm going to multiply by the derivative of h cubed. And the derivative is going to be 3h squared times the derivative of h. So notice my 3's are going to cancel. My whole goal is I need to solve for the derivative of h. So I'm going to have dv is times, right, I'm just going to put 1 so I know what's going to be in the numerator, what's going to be in the denominator. So we're going to multiply by the reciprocal. So it's going to be 841 over 400 pi h squared. So we know, we're going to go ahead and substitute everything we know. We know that the rate of change of the volume is 15. and we want to know at the specific moment when the height is 13. So DH turns out to be 0.0594, and my units are meters per second. So the rate of change of the height when the height is 13 is 0.04594 meters per second. Part B asks, how fast is the radius of the water surface changing at that moment? So part B, we want to find what dr is. So since we don't know anything about dr, we're going to use the formula that we already found in part A. And here's my formula. So I'm going to use R is equal to 20 over 29H. So I'm going to take the derivative of this. So the derivative of R is going to be 20 over 29 times the derivative of H. So what this represents, it represents that the rate of change of the radius only depends on the rate of change of the height. I already found what the rate of change is the height at this specific moment in time when H is 13 in part A. So I'm just going to go ahead and substitute that into my equation. So dr is going to be 0.040965, and my units are meters per second.